Sir,
Okay. So as you can see, the heading is origin of bands in solid. Okay. So what is the reason we get bands in solids? Okay. So and why we do need this band theory? So already we have seen that if you use the free electron theory, and using this free electron theory, we can explain many properties of metal. But why some solids are semiconductors, some behave like insulators, and what about their properties? Okay, so in order to explain those all these things, okay, we need band theory of solids. Okay, so we know what is free particle, huh? Free electron. Okay, so if we free electron and we want to get its wave function, we can solve the Schrodinger equation. Okay, what is the free particle Schrodinger equation? We can write this 2m e upon h cut square psi equals to 0. Okay, can we write like this for free electron particle?
yes, sir.
Okay, so this is the free electron particle Schrodinger equations. Okay, and we know the for free particle, my psi is given by the wave function is given by psi x is equal to e power iota kx. Okay, they are plane waves. Okay, so they are the wave function for a free particle. Okay, for free particle, that means there's no potential, v is equal to 0. Okay, so psi x is this is the equation and it's the value of psi. Okay, now I know when my particle is free, then that means what, there's no boundary. Okay, so when I'm not applying any boundary, that means my k is continuous. Okay, so we know the relation between energy and key, energy and wave vector k is given by h cut square k square by 2m. Okay, so this is for free particle. So when my particle is free, it can have any energy. Okay, that means if I draw my energy diagram, okay, so my energy can take any value. Okay, so this is my energy is continuous. Okay, so this is continuous. This is called energy continuum of a free particle. Energy continuum of a free electron. Okay, so k is continuous, k is continuous, k can take any values, k is continuous because there is no boundaries. So your energy levels are continuous for free particle. Okay, this is the one thing. This we have seen free particle. Okay, and after that we have discussed quantum theory of free electron particle. Okay, that is called Sommerfeld theory. And in Sommerfeld theory में हमने क्या लिखा था? We have considered a boundaries for the electron. Okay, we have assumed that my particle, now my electron is in a box. Okay, in three-dimensional box or one-dimensional box. Okay, so now when I apply boundaries, okay, so this is a free particle. Okay, now if my particle is bound, okay, and bound is very tightly bound का मतलब क्या है कि किसी एक रीजन में किसी एक पर्टिकुलर रीजन में बाउंड है. Okay, then if you want to see their energies, okay, so how can we see, how can we get their energy levels? Okay, so can I rub this one?
Yes, sir. Yes, sir.
So
सर इसमें हम लोग एज्यूम कर रहे हैं कि हमारा पार्टिकल एक पर्टिकुलर रीजन में टाइटली बाउंड है, राइट?
हाँ, फिर भी अगर आपने पार्टिकल बॉक्स ले लिया या वन डायमेंशनल बॉक्स ले लिया, तो वो पार्टिकल तो द वॉल्स आर इनफाइनाइट ना, इनफाइनाइट पोटेंशियल. So
Yes,
that
right, sir.
so that particle is free only in a small region. Okay, but it is confined in one place. Okay, जैसे एक आयन when we have ions. Okay, so that electron is confined to that potential of that ion. Okay, so now this is free electron particle. Now we are going to discuss what happens when we have bound electron. Okay, let it dry. Dry cloth तो नहीं रख दिया. So now put the second heading. The second heading is okay, electron in a potential well. Okay, electron in a potential well. Okay. So here I am assuming the potential well is one dimensional. So if my potential is one dimensional, okay, consider 1D potential well, 1D potential well. Okay. So if my particle is 1D potential, okay, I know what is my energy. My energy is given by what? N square, pi square, h cut square upon 2m square. Okay, isn't it?
Yes, sir.
Okay, this is my energy relation. Okay, and my k value is what? N pi by a. Okay.
Yes, sir.
K can take n pi by, and if I want to write the wave function, okay, for particle in box, so the wave function of particle in box is what? Under root 2a upon sine n pi x by a. So this is the energy. So now as soon as you apply the boundaries, okay, what happens? My energy levels become discrete. Okay, my k values are not continuous. Okay, जैसे free particle में k value continuous थी, energy continuous थी. So now instead of what you'll get here energy levels. Okay, atomic like energy levels. Okay, so suppose if I want to write this energy En, so this En will be what? N square E naught. Okay, where E naught is the ground state energy, pi square h cut square 2m square. Okay, so that means now my energies, okay, where n is what? N is 1 to 3. So if I want to write, this is my ground state energy E naught. Okay, then I have 2 E naught. Okay, now if you put 1, okay, so for 1 I have E naught, 2 I have 4 E naught. Okay, for 2 I have 4 E naught. So 9, then we have a 9 E naught, then we have a 16 E naught. Okay, so जैसे ही हमने we applied boundaries, okay, तो हमको हमारे पास क्या है अब डिस्क्रीट लेवल्स है, एटॉमिक लाइक एनर्जी लेवल्स है. ओके, ये समझ में आ रहा है ना क्या बोल रहा हूँ मैं? जब पार्टिकल फ्री है तो हमारे पास एनर्जी कंटिन्यूअस है. जैसे हमने बाउंड्री लगाया हमारे पास क्या आ गया? एनर्जी लेवल्स आ गए जो कि डिस्क्रीट्स हैं. ओके, नाउ अगर नाउ यू वांट टू सी इन रियल क्रिस्टल. ओके, रियल सॉलिड में क्या होता है? ओके, सो व्हेन वी आर इन रियल सॉलिड, ओके, सो इन रियल सॉलिड देयर इज अ पोटेंशियल. ओके, इसको रब कर दूं? कैन आई रब दिस वन?
Yes, sir.
Yes, sir.
Okay.
Sir, here we are talking about for only one electron.
Yes.
But sir, in solid there is the number of electrons. So कैसे सर ये मतलब एक एक पोटेंशियल वेल हो रहा है?
क्वालिटेटिवली तो सेम ही होगा ना. अभी हम इसमें अभी हम खाली उसके एनर्जी लेवल्स देख रहे हैं, फिलिंग नहीं कर रहे हैं हम लोग. ठीक है, जैसे तुम बात कर रहे हो, जैसे इलेक्ट्रॉन फिल करने की बात कर रहे हो कि जैसे एक इलेक्ट्रॉन है तो कहाँ जाएगा, 2 n है तो वो वेल में कैसे फिल होंगे. अभी हम उसकी बात नहीं कर रहे हैं, हम खाली इलेक्ट्रॉन के एनर्जी डायग्राम की बात कर रहे हैं कि बैंड. अभी व्हाट आई एम ट्राइंग टू डिस्कस हियर, हाउ बैंड्स आर फॉर्म. ओके, सो फॉर एग्जांपल now we want to see the real solid case. Okay, so real solid case means if I have a potential. Okay, so in real solid I have a ions. Okay, now we know if I want to draw the potential of an ion, how can I draw? What is the potential of an ion?
KQ by R के फॉर्म में होता है तो
KQ by R. Okay.
yes sir.
So that is called Coulomb potential. Okay. But this is when we see in real crystal, we don't have a Coulomb potential. Okay, we have a screened Coulomb potential, which is similar nature. Only if so, suppose I want to draw the Coulomb potentials. Okay, so this will be my Coulomb potential. Okay, so in real solid, instead of this Coulomb potential, okay, we have a screened Coulomb potential. So that has the same shape. उसका भी shape same ही है, but instead of this one, we have a little bit steeper slope. Okay, so this is my potential in a solid. Okay, so if I draw this potential, okay, this potential in solid, okay, so I get this kind of profile. So this is the exact profile of a electron, which electron sees in a real solid. Okay, now if you want to solve the Schrodinger equation, we have to solve.
सर
बोलिए.
सर ये जो means you have written plus plus is electrons, right?
These are ions.
Or
Okay.
ions.
So
Okay.
this is the potential. Okay, periodic potential.
And the gap between them is potential.
Gap नहीं है potential. Periodic potential in a crystal. Okay. So just now I told you that potential is given by V by KQ upon R.
Yes,
Okay.
sir.
So this is 1 upon R dependence. If electron is moving away from the this ion charge, okay. So this is the curve.
Yes,
If I draw V equal to KQ by V equal to R, so this will be the shape, na? This type of shape.
yes, sir. Yes, sir. Yes, sir.
So this I'm drawing here. Okay. So when I'm moving from ions away, so I'm drawing that potential.
I will move along this path.
Yeah. So
Okay.
so this is the form of potential, okay, in a crystal. Okay, now if you want to get, I want to get the energy of this electron. Okay, I need to solve the Schrodinger equation for this potential. Okay, which you might have studied in college. Okay, solid state physics. Okay, this type of potential is not solvable. Okay, so so we can, what we can do, instead of solving this potential, we can simplify this potential with a potential which is solvable. Okay, so advantage what we have, that Bloch, okay, Bloch has given a theorem, okay, which says, okay, so in order to solve this kind of periodic potential, Bloch has given theorem that is called Bloch theorem. So Bloch theorem says that in a periodic potential, in a periodic potential, the solution of Schrodinger equation, okay, are Bloch functions. अभी हमने देखा जब हम फ्री पार्टिकल ले रहे थे या फ्री पार्टिकल इन अ बॉक्स ले रहे थे, तब हमारा वेव फंक्शन क्या था, प्लेन वेव था. ओके, नाउ Bloch says, okay, Bloch theorem says whenever your electron will move in a periodic potential, okay, in that case your solution will not be a plane wave. हमारा पास जो प्लेन वेव है e पावर आइटा kx, हमारा जो वेव का फंक्शन है वो e पावर आइटा kx नहीं होगा. ओके, इंस्टेड ऑफ दैट solution will be Bloch wave solutions. Okay, now what is Bloch wave solutions? So Bloch wave solutions are given by k r equals to exponential iota kr, दिख रहा है ना, iota kr, okay, u kr. Okay, so the solution of Schrodinger equation for periodic potential. Okay, so that will be multiplication of what? Your plane wave solution, and that will be modulated by a function, okay, which has the same periodicity like your lattice. Okay, so suppose if I assume that this potential is is uh, is repeated periodic with d. Okay, so if I say if this is a one-dimensional potential and 1 plus xd is equal to vx. Okay, so this potential is getting repeated by distance d. Okay, so in that condition I can write the solution of Schrodinger equation in terms of block functions. Okay, where this ukr should have a same periodicity like your lattice or your given potential. Okay, so where I also can write
So may I ask a question, sir?
बोलिए.
Sir, this solution represent what? Means how the what is the means what does this solution represent?
The block theorem says, जैसे अभी हमने लिखा फ्री पार्टिकल के लिए बॉक्स के लिए हमारे पास प्लेन वेव सॉल्यूशंस थे. Okay,
Yes, sir.
so similarly block theorem that we can that is mathematically proved. Okay, we are not giving proof here. So if there is a periodic potential, okay, तो उस periodic potential में जो wave function होंगे that will satisfy blocks property. Okay, that will be block wave type of functions. There will be that kind of functions. Okay, where here your UK R, okay, is equal to your UK R, okay, if the periodicity if it is getting repeated by distance vector and three dimensions. Okay, so I can write where UKR. What is UKR? So UKR, okay, UKR is a space dependent okay, amplitude function. Okay, space dependent amplitude function.
Sir, which one is the periodicity?
Which related? Pardon? क्या बोला?
UKR here smaller is the parameter.
Small r is the our normal position vector. Okay, and is the periodicity is repeated by vector r. Okay,
In the right hand side it should be smaller. No?
Small r, yes, correct, it should be smaller. Thank you. Okay, so which related, okay, or which
Sir, ये भी small.
which one, which is small? Here, yes, yes. UKR, the space dependent amplitude function which related, okay, or which reflect the periodicity of lattice or potential. Okay, potential. Okay, now I can also write using these two equations. Okay, I can also write, if I want to write psi, okay, k r plus r. Okay, so if I want to write this one, what I can write, यहाँ पे क्या लिख सकता हूँ मैं? Iota
IKR
k plus r, okay, psi, what I can write here, psi k r,
KR
K dot R. What is
Hmm?
K sir?
फिर वो K dot R होगा.
k dot r, k dot r,
K
sorry,
dot R sir.
k dot r plus r.
K dot
Okay,
capital. Yeah.
r
It's
plus r.
fine.
ठीक है, r plus r. और यहाँ पर what will be here? Okay, so psi k dot k dash r. This is correct. So sorry.
It will be IK dot capital R only.
So let me write this definition. What is block function? Okay, then let me write this one. Okay, so what is my block function? Okay, my block function is, okay, psi k r is equal to exponential iota k dot r. Okay, and u k r. Okay, now if I want to write psi x plus r, okay, so if I want to write now psi k r plus r, okay, so I can write iota, okay, k dot r plus r, okay, and this I can write what, u k r plus r, okay, and this I can write iota k r, okay, and iota k dot r, okay, and this is equal to what? This is equal to u k r, okay, and this is what, this is our psi k r. So this will become iota k dot r. This becomes psi k r. Okay, so this is our k r plus r, okay, is equal to iota k r psi k r. Okay, so what does this equation tell us? Anyone? इस इक्वेशन से हमको क्या पता चल रहा है?
So the wave function is not periodic now.
How?
So because e to the power I k dot r का एक phase factor आ रहा है.
So I'm saying that when I move, okay, so I'm writing it in one dimension. Okay, so if I want to write this 1D in 1D, I can write psi k, okay, if periodicity is by d x plus d, okay, I can write it as iota kd, okay, is one dimension, and this becomes psi k x, okay. So when I'm moving from x to x plus d, okay, when I'm moving from x plus to xd, okay, so now these two functions are same, okay, so if I can write also this psi x plus d, because my wave function is also this periodic, so can I write like this psi k x? Can I write like this?
Yes sir.
By
सर लेकिन हमारा जो आई के फाइव का फैक्टर वो तो रहेगा ना?
this is what psi kx, okay, so just now I gave you the block properties. So block says psi kr can be written as iota kd, okay, iota kr, okay, kx, here is kx, okay, sorry, I'm writing here kx psi
No,
k,
KD sir is fine.
is kd or kx is correct?
KD sir. Yes.
KD. Okay, so if I so what is actually meaning of this one? Okay, so when you are moving from x to x plus d, you're moving from x to x plus d in k space. What is how much is the movement when you're moving from x to x plus d?
D is the moment.
So in in k space, you're moving from what? By 2 pi by d.
Yes, sir.
Okay, in k space, actually, when you're moving by 2 pi d. Okay, so what these equations tell us that the wave function, let me write first, then I'll explain. The wave function is same. Wave function is same for two values of k which satisfy okay, or which differ by integral multiple of 2 pi by d. Integral multiple of 2 pi by d. Okay, integral multiple of 2 pi by d. Okay, so that means your wave function will not change.
After wave function, what you have written, sir? Wave function is
Where the wave function is same for two values of k which differ by integral multiple of 2 pi by d. Okay, so if we put k equal to k plus 2 pi by d, 4 pi by d, n pi by d, okay, your wave function will not change. Wave function will be always same. Okay, so there is a period in k 2 pi by d. Yes,
सर x और x प्लस डी के बीच में k स्पेस में डिफरेंस 2 पाई बाई डी कैसे आएगा?
यही तो हमने इतनी दिन से यही तो कर रहे थे
सर अगर हम x पॉइंट को k स्पेस में रिप्रेजेंट करेंगे तो वो 2 पाई बाई x हो जाएगा। और जो x प्लस डी है,
k क्या होता है हमारा? 2 पाई बाई लैम्बडा तो होता है। ओके, लैम्बडा क्या है आपका x स्पेस में है और k क्या है आपका रेसिप्रोकल स्पेस में है। जब हम बात कर रहे थे कि यूनिट सेल का डायमेंशन क्या है, यूनिट सेल का वॉल्यूम क्या है, तो हम डायमेंशन कैसे लेते हैं? 2 पाई बाय lx, 2 पाई बाय ly, 2 पाई बाय lz, ऐसे तो ले रहे थे when we are calculating volume of the unit cell. That was 2 pi by l cube. Okay, that means दो lattice points के बीच में k space में distance कितना था? 2 pi by l था ना, 2 pi by lx था। Okay, so if the in lattice, if you have distance d, okay, in k space your distance is 2 pi by d. Okay, so now if you so what I can write here, so what I'm trying to say here, that after every 2 pi by d, okay, your value will repeat like we have done in the first when we are doing this 4 on curve. Okay, that time what we done, we have restricted our k value between minus pi by a to plus pi by a. Okay, so similarly we can restrict here also, we can restrict, okay, k values, okay, from minus pi by a to plus pi by a. Okay, one thing is this. Okay, second thing, if I apply periodic boundary conditions on a chain of lattice, okay, if we apply for a linear okay, periodic chain of n atom, okay, for a linear periodic chain of n atoms, okay, of period d, okay, periodic boundary conditions, okay, but periodic boundary condition gives, okay, can be periodic boundary condition can be written as, okay, so how can we write periodic boundary conditions? So if I want to write this periodic boundary conditions, okay, so what I can write my psi kx, okay, equals to psi k plus x plus d, okay, and this is equal to psi k, okay, psi k. If there are n atoms, okay, I can write this is as nd, so psi k x plus nd, okay, and this is equal to okay, I can write this one as psi exponential it k. Let me write, then I'll explain. Okay, nd, okay, psi kx, okay. So what we are doing in periodic boundary conditions, okay, suppose we have a n lattice points, 1 2 3 4, okay. So when we apply periodic boundary conditions, okay, on atoms, we say that we told in the beginning the vibration is same, okay, at endpoints, okay. So if you have chain of atoms, so in periodic boundary condition, what we say that at the ends, okay, at two end points, okay, the my amplitude is same. Similarly, here we apply periodic boundary condition on n atoms, okay. So we say this wave function is same. Wave function is repeated by after going from n atoms, okay. So this what this will give us. So this will again will give you same conditions which we are doing repeatedly. So this will give me restriction on k values, okay. So this will give me what, psi k and d. So this will give me what, psi iota k and d, okay. So both are same, okay. So this is equal to 1, okay, which I can write e power iota 2n pi, okay, 2n pi, okay. So if I solve this one, okay, so what will I get? I will get the k values. I will get the k values 2 n pi upon n d, okay. This is clear? Alok,
So what is psi I k n d?
which one?
The psi I k n d root equal to 1.
Sine, sorry,
First
iota.
time.
So sine is iota. So it's iota. This term I'm writing iota k and d, iota k and d, okay. These two functions are same, okay. So this should be what, equal to 1, na?
Yes, sir. Yes.
Okay. So this will give me
Should be
k.
equal to 1.
So this will give me k value 2 n pi and d, okay. Now I told you that I am restricting my k values from plus pi by a to minus pi by a, okay. So if I put here k equal to pi by a, what will be value of n?
Pi by d, right?
If I write here, I am restricting my values. If I'm restricting my values k equal to pi by a, okay. So what will give me 2 pi n d, pi se pi cancel ho gaya, okay. So what I'll get, n equal to what I'll get 2 pi
by d होना चाहिए ना,
pi by d, yes, pi by d. So what I'll get, n by 2, isn't it? ऐसा मिलेगा नहीं मिलेगा? If I put,
Yes.
okay, similarly if I put minus pi by d, okay, then also I'll get what, n equal to what, minus n by 2. If I put here minus pi by d, okay. So what I'm trying to say that between minus pi by d to plus pi by d, okay, n has how many values? This n small n can take n values. Small n can take n values. और n क्या है?
n
number
plus
of
1.
number of atoms. Okay, so when n is a number of atom, that means n can take capital N values. That means my k also can take n values. Okay, so वो ये चीज में हम पहले भी रिपीट कर चुके हैं कि जितने भी लेटिस पॉइंट होंगे, ओके, उतने ही k स्टेट्स होंगी. So the same thing we are again proving here. That means there are n distinct values for n. There are n distinct values,
Sir,
for n. Okay, hence same for k. हाँ, आप बताइए.
sir, small n is means number of
Small n is number na. Be iota k is iota k and d is iota 2 and pi. Okay, so iota 2 and pi, where n is what? N is what? 0, 1, 2, 3. Okay, so now when I'm restricting my k values from minus pi by d to pi by d. Okay, so n can have total n values. Okay, so when n can have this n can have total n values. Okay, that means my k also can have total n values. Okay, so that means my k in between minus pi by d to pi by d, my k can have n distinct values. That means my k can have a n k that and k can have a n states. Okay.
Okay, sir. N represent capital N represent n different states.
The capital N represent number of atom. Okay.
Oh,
So अगर pi by d से minus pi by d से pi by d के बीच में k can take n values. Okay. 0 to pi by d, it can take n by 2 values, and 0 to minus pi by d, it can take minus again n by 2 values. That means between pi by d to minus pi by d to pi by d, my k can take n values. Okay, that I'm trying to say. That means make k की कितनी स्टेट होंगी? जितने की लेटेस्ट पॉइंट होंगे.
okay, sir.
Sir,
हाँ,
n plus 1 it should be, no? Because n can be 0 also.
हाँ.
So we are neglecting 1 because of large number of n.
So we are neglecting that because we are doing periodic boundary condition. Na? This atom will become same.
Yes, sir.
This atom will become same. Na? भी अगर जब क्रिस्टल हम करते हैं, suppose this 1, 2, 3, 4, 5. Okay, so if I put this lattice point A, 2, 3, 4. So 1, 2, 3, 4, 5. There are 5 atoms. We get total 4a distance. Na? 4a distance. Okay, and this distance. Okay, now if I'm merging this two together, suppose this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so say this is n equals to 0 and this is n equal to 8. Okay, so this is a. How many become? A 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's same thing we written here, na? That k is equal to nd. Okay.
Yes, sir.
So so from here the thing is that we are getting जितने atom होंगे उतनी हमारे पास k state होंगी, and we have seen in the case of electron there is a spin degeneracy of 2. So you have to for electron state you have to multiply by 2. Okay, to k states if you want to get electron states. Okay, now this is the one thing. Now actually today what we are doing, we are trying to calculate the energy EK relations, or we are trying to explain what is the origin of bands in solid. Okay, so in the beginning I have taken the free particle case. Okay, then I have taken when there's a boundaries like periodic potential, when there's a potential well. Now we are taking what periodic boundary condition. Okay, so put the heading now, Croning-Penning model. Croning-Penning model. Okay, so Just now we have seen that we have a crystal. Okay, so in crystal we have this kind of potential. Okay, and this type of potential is with this kind of potential, your Schrodinger equation is not solvable. So what we do, we approximate this potential, okay, by a simpler square wave potential, which is the same periodicity of this lattice. Okay, so suppose this is my region first. Okay, so here say this is the potential 0. Okay, this is ux, and this is also my ux. Okay, and say this potential is 0, and this potential is my v naught. Okay, now say this is my region 1 and this is my region 2. Okay, so say this distance between, say this is the 0 and this is my a, and say this is minus my minus b. Okay, so this is the periodic potential. Okay, so if I take this value, okay, so this value will be repeated by what, b and a. So after d equals to a plus b, this potential will be repeated. Okay, that means this is a periodic potential which I can write x plus d equal to vx. Okay, so since we cannot solve this kind of potential Schrodinger equation, we are using a simpler model which is solvable. Okay, and qualitatively will not lose any information. Okay, what qualitative information we want to get, we can also get with this same square wave potentials. Okay, now in order to solve this potential, what I need, in order to solve this potential, I need to solve the
ये जो potential का width है ये अलग अलग है क्या?
हाँ,
मतलब length
ये लेंथ अलग अलग है. ये डिस्टेंस है आपका b और ये आपका डिस्टेंस है आपका a. Okay,
okay sir.
So if I want to solve the Schrodinger equation, okay, in region first, okay, say in region first, okay,
सर ये a एक्चुअली क्या है, ये आयन का डायमीटर है क्या?
ये डिस्टेंस हम बोल रहे हैं, इस गैप को डिस्टेंस बोल रहे हैं. ये हम ये बोल रहे हैं, ये जो पोटेंशियल है आपका, ओके, वो d डिस्टेंस के बाद रिपीट हो रहा है. तो जो पोटेंशियल है d डिस्टेंस के बाद रिपीट हो रहा है. यहाँ पर इस डिस्टेंस को आप d बोल दो. Okay,
okay sir, okay.
So now in region 1, what I can write, region 1 is what, when your x is between 0 to a. Okay, so if I want to write my Schrodinger equation, यहाँ पे Schrodinger equation क्या होगी इसकी region 1 में? What is the potential inside?
free particle
वाला हो जाएगा. Okay, so if I want to write, I'm erasing this one. So if I want to write the Schrodinger equations, okay, then the Schrodinger equation will be d2 psi upon dx square plus alpha square psi equals to 0, where my alpha is what? Alpha is what? 2m
upon h
square. Okay, so we are not going rigorous mathematics. We are just today we're trying to show what is the origin of beds in solids. Okay, what is alpha square?
Alpha square.
Yes, alpha square. Correct. So this is alpha square. Similarly, if I want to write in region second, region second is what? Region second is from minus b to 0. So minus b to 0. Okay, if I want to write my Schrodinger equation, क्या लिख सकते हैं Schrodinger equation?
वो बीटा स्क्वायर लिख दीजिए, वो माइनस v नॉट हो जाएगा.
This will be d2 psi square dx square. I can write here beta square psi equals to 0, where beta square will be what? 2m v naught minus e upon h cut square. ये सब तो तुम किया है क्वांटम में ना? Okay, where v naught is what? This step. Okay, So now if I want to write the solution of these two equations, I'm not going to solve these equations. Okay, just we are qualitatively we try to understanding why do band arises in solids. Okay, so now if I write the solution of these two equations,
सर
हाँ
सर रीजन 1 में V नॉट पोटेंशियल होगा ना, 2 में तो पोटेंशियल 0 होगा।
अभी तो प्लॉट किया था मैंने, आप अच्छे से देखो उसको। वी नॉट कहाँ पर है, -b to 0 है ना, 0 to a में तो 0 पोटेंशियल है।
Yes, sir.
ओके सर, ओके सर।
Okay, now if you want to write a solution of this equation, इसका solution क्या हो जाएगा, psi x equal to a iota kx, okay, plus b e power minus iota kx, okay. Similarly, if I write, so they say this is psi 1, okay, and suppose if I want to write a solution of this equation, okay, क्या solution होगा इसका,
To the power
to the power
k,
beta
और
to the
gamma
power
x beta x
minus
kx c, okay, so let it write c kx or beta x,
sir, not k.
beta होगा सर beta
so beta x, okay, plus d e power
to the power
minus
Minus b.
beta x, okay,
इधर भी alpha होगा फिर.
इधर alpha है, okay, thank you, this is also alpha, okay. Now these are the general solutions of these equations. Okay, now you know how to solve these equations. Okay, when you will apply about boundary conditions. Okay, you'll apply boundary conditions that and properties of psi, that psi should be differentiable at the boundaries, and same thingly you will apply when block properties. Okay, so when you solve this equation, okay, so we need that energy versus k relation. Okay, so when we apply these boundary conditions, and the derivation is given in many books. Okay, so derivation is, you know, this Crony pairing model is very 2 to 3 page long derivation. Okay, so we don't require to do this here because we only need final information. So when we solve these equations, okay, what we get, that final answer I'm writing here, which will explain us why do we get bands. Okay, so when we solve these equations, okay, then what we get? We get the equation cos k, okay, p sine alpha a upon alpha a, okay, plus cos alpha a, okay, where my p is what? My p is m a, okay, h cut square v naught b, okay. ये पहले सॉल्यूशन देखे होंगे, ये दो सॉल्यूशन देखे होंगे ना।
हाँ सर,
ये कॉर्निंग बर्डिंग मॉडल तो हम सॉलिड फिजिक्स में करते ही हैं, खास जब एमएससी में होते हैं ये चीज, और डेरिवेशन भी आपने किया ही होगा, काफी लंबा चौड़ा डेरिवेशन है। ओके, बट हमको क्या करना है, खाली इसको क्वालिटेटिवली अंडरस्टैंड करना है। ओके, सो नाउ v0b is what? v0b is the strength of the potential, strength of potential. Now I want to solve. हाँ,
मेरा थोड़ा नेटवर्क चला गया सर, क्या बोला सर बीच में?
अभी मैंने
सॉल्यूशन के बाद सर।
हाँ, अभी हमने क्या किया, हमने क्रॉनिक पैटर्न पहले जो हमारा जो स्क्वायर पोटेंशियल था, ओके ना, उसको श्रोडिंगर इक्वेशन में पुट किया। ओके, रीजन 1 रीजन 2 में वी रॉट सम एक्सप्रेशंस। नाउ उसके बाद क्या करना था, हमको बाउंड्री कंडीशन लगानी थी, बाउंड्री कंडीशन और साइज और जो वेव फंक्शन की प्रॉपर्टी लगानी थी, एंड देन नीड टू सॉल्व। ओके, सो आई एम राइटिंग नाउ फाइनल आंसर। ओके, व्हेन वी सॉल्व these applying boundary conditions and using the block wave function properties. Okay, so because we are using this periodic potential, so your wave function will be also block wave functions. So when we solve all these proper applying these boundary conditions, okay, we get this final expression. Okay, now from this we have to get the ek relations. Okay, or we have to explain why there are bands in solids. Okay, so now we P is also sometimes this is called strength. Okay, so in general they say V0B is the strength of potential. Okay, so P shows what is the how effective your potential is there, or what is the strength. Okay, now this model should explain us two things. Okay, so when there is a no potential, when your P is 0, okay, so this model should give us what? Same type of energy levels what we got from free particle. Okay, similarly if this P is this strength is very high, when P is infinite, is bound, we should get what? We should get or our potential well type of energy levels. Okay, and in between those two reasons, okay, or two values, okay, you should get bands. So let us see how to analyze these two equations. Okay, so this equation
Sir, after P0, what do you have told, sir?
which
Then-
P0?
Sir, here you have told that P0, then you get what?
भी अगर potential 0 है, if this term is 0, it is
Yes,
0,
sir.
तो हमारा क्या हो जाएगा? Free particle हो जाएगा. Okay, so when we'll put P is equal to 0, ये जो solution है हमको free particle type energy level देना चाहिए. Similarly जब P infinite है, okay, this solution, this should give us like a atomic like energy levels. Okay, and in between this 0 to infinite, this should give us what? It should give us bands. So let us analyze this expression. So now I want to analyze this, solve this equation, and we can see this equation can be solved only graphically. So if I plot this equation, okay, if I plot this equation, so we know this equation थोड़ा कम स्टिप करना. So if we solve this, now from here, from right hand side, you can see there is a cos k. Okay, नहीं कट रहा है क्या नीचे?
Yes, sir.
Okay, so let me draw above. Okay, so let us understand now this equation. Okay, so we have okay, so this is my P. Okay, and P is what? P is P की वैल्यू क्या है? Sorry,
MV not B. MA.
so y axis पे what we have? We have this one P sin alpha A upon alpha A plus sin alpha A. Okay, and next axis पे we have? We have alpha A. Okay, so we are plotting this equation. Okay, the equation what we have P sin alpha A upon alpha A, okay, plus cos alpha A, and that is equal to our cos k. Okay, so first we have plotted this equation with respect to A. Now my cos k can take maximum value from -1 to +1. Okay, so if I take my k values, okay, cos k, so cos k can take maximum -1 to +1. Okay, so this is a +1 and this is -1. Okay, now you all know what is alpha here. Alpha is related with energy. Okay, that is 2m p upon h cut square. Okay, now what are the allowed values of alpha A? Okay, what what will the allowed value for alpha A? Just see the graph and tell me. What is the allowed value of alpha A? If this equation, अगर हमको इस इक्वेशन को सॉल्व करना है तो ये क्या है?
Yes, sir.
-1 से 1 के बीच में जाएगा।
It should be between
Yes, sir.
1 and -1.
तो ये भी -1 से 1 के बीच में जाना चाहिए।
यस सर, यस सर।
ओके, तो अल्फा जो यहाँ पे जो हमने अल्फा ए ड्रॉ किया है, ओके, वो कहाँ है? -1 से 1 के बीच में। तो 1 कहाँ पर है? यहाँ पे क्या है? दिस इज 1 और -1 कहाँ पर है? यहाँ पर। तो दिस इज द अलाउड वैल्यू ऑफ अल्फा। ओके, सपोज माय अल्फा ए इज पाई। ओके, इफ अल्फा ए इज पाई, if alpha is pi, 2 pi, 3 pi, 4 pi, this term will become 0.
Yes sir.
Okay, so if alpha a equal to pi, if pi, so this term what will become 1. Okay,
Yes sir.
plus 1. Okay, so so what is the alpha value here? Pi. Okay, now similarly if I want to write 2 pi, 3 pi, so this is the allowed values. Okay, so this is
pi पे वैल्यू -1
तो cos pi -1 ना।
इसको थोड़ा सा ड्रॉ ऐसे कर लो वरना थोड़ा गड़बड़ हो जाएगा। हाँ, अगर मैं बोल रहा हूँ अल्फा ए इक्वल टू पाई है, ओके, तो ये क्या हो जाएगा? माइनस, सर करेक्ट। ओके, सो अल्फा इक्वल टू पाई, so this will be my minus value. Okay, similarly if alpha a equal to 2 pi, okay, so this position is 1, so this position, so this will be my 2 pi. Okay, so these are the allowed values of, so if I say this one, so this is my allowed value of alpha a. Okay, so this is my allowed value of alpha a. Okay, similarly if I say this is 2 pi, okay, from -1 to +1, okay, so this is my -1 and this is my +1, so this graph, okay, this one, okay, so this one is my allowed value. Okay, so if I take this one, this is my allowed value, this is my allowed value of alpha. Okay, so now what I'm trying to say by plotting this graph, okay, so by plot
cos alpha,
which one? This one, huh? Cos alpha a. Okay, so by plotting, हाँ
सर ये जो पाई आपने कहा है सर, ये कल -1 के लिए +1 के लिए सर?
-1 के लिए, -1 के लिए,
-1 के लिए सर। और
यहाँ पे तुम यहाँ पे अगर तुम यहाँ पे अल्फा इक्वल टू पाई रखोगे तो ये टर्म 0 हो जाएगा। ओके, तो ये वैल्यू क्या हो जाएगा? cos अल्फा क्या हो जाएगा? cos पाई क्या हो जाएगा? -1 हो जाएगा ना, तो ये जो
-1 हो जाएगा सर,
-1 हो जाएगा ये वाला। ठीक है, तो ये वैल्यू पाई है।
और फिर सर 0 के लिए फिर वो नीचे ना सर,
क्या?
क्योंकि +1 पे किससे होगी सर?
सर जो पीछे वाला मतलब +1 के करस्पॉन्डिंग आ रहा है वो कैसे आ रहा है?
कौन सा वाला
सर जो +1 के करस्पॉन्डिंग
अपर साइड में सर,
ये वाला
जो अपर बाउंड्री, यस सर, ये +1।
एक मिनट, सो दिस इज योर पाई, तो ये यहाँ से आ रहा है ना अभी, ये आपका ये पूरा कर्व अलाउड है ना, जहां पे आपका अल्फा का वैल्यू आ रहा है, इस कर्व पे, इस कर्व के करस्पॉन्डिंग जो अल्फा ए का वैल्यू है, इसके करस्पॉन्डिंग जो अल्फा है, इसके करस्पॉन्डिंग जो अल्फा है, वो तो मैंने पाई लिख के बताया आपको कि इस पे इतना वैल्यू आ रहा है। ओके, आपका अलाउड वैल्यूज तो ये सारी है ना।
अच्छा, यस सर,
ये सारी अलाउड वैल्यूज है ना, यहाँ से लेके यहाँ तक, जो ये आपका वाई
पीछे कितना होगा सर?
हाँ
सर इसका मतलब ये नहीं पता पीछे वाली बाउंड्री कितनी,
पीछे वाला पता नहीं है, अल्फा पता नहीं है पीछे। ठीक है, तो यहाँ पर जब भी आपका अल्फा ए होगा, पाई अल्फा ए इक्वल टू पाई होगा, अल्फा इक्वल टू 2 पाई होगा, ये टर्म 0 पे जाएगी, तो आपका cos अल्फा इक्वल टू cos k हो जाएगा। ओके, तो जहां पर आपका अल्फा ए इक्वल टू पाई है, वहां k इक्वल टू भी पाई है। क्लियर?
यस सर।
ओके, आपका k इक्वल टू भी 2 पाई है, ये चीज ध्यान रखनी है। नाउ इस ग्राफ से क्या कंक्लूजन निकल रहा है? सबसे पहला कंक्लूजन तो ये निकल रहा है इस ग्राफ से कि whenever you have a periodic potential, okay, then you have a then you have a the range of there is a allowed range of alpha value. That means there is allowed range of alpha values, and between these allowed value of alpha energies you have forbidden gaps. Okay, that means you are getting bands. Okay, so number one conclusion क्या है इस ग्राफ से? Okay, so you can write number one conclusion. So conclusion number one. Conclusion number one, you can write the motion of electron. The motion of electron in periodic potential. In periodic potential. Okay, the motion of electron in periodic potential is characterized by the bands of allowed energy, by the bands of allowed energies. दिख रहा है ना? separated by forbidden gaps. ओके, सो पहली चीज तो हमको क्लियर हो गई जो आज का हमारा पर्पस था. ओके, कि हमारे को बैंड्स कब मिलेंगे? बैंड तब मिलते हैं. ओके, फिजिक्स हम बाद में देखेंगे, पहले हम पोटेंशियल के टर्म से बात कर रहे हैं. अगर फ्री पोटेंशियल है तो आपके पास कंटिन्यूस लेवल है. ओके, आपके पास में बाउंड्रीज हैं, शार्प बाउंड्रीज हैं, या टाइट पोटेंशियल या हाई पोटेंशियल है. Then you have a discrete energy level like atoms, and the final when you have a periodic potential, okay, then you have a bands. Okay, so this is the number one conclusion. Now number two conclusion we can write. इसको erase कर दूं क्या मैं?
सर वो conclusion बचे रहने दीजिए.
हाँ conclusion ठीक है.
सर conclusion you have told कि जो forbidden gaps के बीच में इलेक्ट्रॉन का जो
जब भी आप पीरियोडिक पोटेंशियल लगाओगे
अलाउड रीजन उसमें मूव करेगा
तो अलाउड रीजन्स होंगे और उसके बीच में फॉरबिडन गैप होंगे. ओके, मतलब आपके पास बैंड होंगे, आपके पास शार्प एनर्जी लेवल नहीं है, आपके पास एक रेंज है. ओके, आपके पास बैंड्स हैं.
यस सर. और
दूसरी चीज हम यहाँ पे देख रहे हैं, जैसे जैसे हम अल्फा ए को बढ़ाते जाएंगे, ओके, जैसे जैसे हम इस अल्फा ए को बढ़ाते जा रहे हैं, आपका बैंड्स भी वाइडर होते जा रहे हैं. ओके, सो पॉइंट नंबर 2. ओके, ग्राफ को जो तो पड़ेगा ही, ज्यादा बड़ा ड्रॉ कर दिया. पॉइंट नंबर 2. ओके, पॉइंट नंबर 2, एज अल्फा ए इंक्रीजेस, ओके, एज अल्फा ए increases, okay, the band gets wider. Okay, the bands get wider. ठीक है, ये पॉइंट क्लियर है?
यस सर.
ओके, आपकी ये जो बैंड है ये वाइड होते जाए, बड़े होते जाएंगे. ओके, now we'll talk about this potential. Okay, so what is the value of P? So the value of P was, what is the value of P? It was ma h cut square. Okay, V naught B. Okay, and where V naught B is what the strength of this potential. Okay, now if this strength of potential is very high, okay, if this strength of this potential is very high, उस केस में क्या होगा? क्या ऑब्जर्व, इस ग्राफ पे क्या ऑब्जर्व होना चाहिए?
डिस्क्रीट ऑर्बिट्स, डिस्क्रीट बैंड्स.
वो तो इनफाइनाइट केस में. ओके, वो इस ग्राफ से कैसे पता चलेगा? अगर इस P को मुझे ज्यादा करूंगा, इफ आई एम गेटिंग दिस P, ओके, P अब अल्फा तो सेम ही है. इफ आई एम इंक्रीजिंग दिस P वैल्यू, व्हाट विल बिकम? this graph
bands थोड़े पतले होते जाएंगे.
Very good. Okay, because this now if I increase the P, what will happen? This slope will become steeper and steeper. अभी ये ऐसा आ रहा है ना, वो और शार्प हो जाएगा. ओके, शार्प होने से क्या हो जाएगा? आपके जो बैंड है that will become स्मॉलर एंड स्मॉलर, उनकी विड्थ है कम होती जाएगी. ओके, एंड व्हेन p is infinite, okay, so when p is infinite, so we'll take, okay, so you can write point number 3, ये लिख दिया ना, as alpha increases band get wider. Now point number 3rd,
Yes, sir.
now point number 3rd,
The band get wider.
हाँ हाँ, भी वाइड
wider मतलब तो चौड़ा होना.
चौड़ा हो रहा है ना, देखो अभी अल्फा इंक्रीज हो रहा है, अल्फा इंक्रीज हो रहा है, तो ये पहले इतना सा था,
Yes, sir. Yes, sir. Yes.
ये वाइडर हो गया. ओके,
Yes, sir.
अब ना पॉइंट नंबर 3rd, now point number 3rd is what, if potential barrier strength, okay, if मैं शॉर्ट में लिख रहा हूँ, if v0b, okay, और ब्रैकेट में लिख देता हूँ p, okay, p is large, if p is large, okay, then what will come, then figure, or then the curve is, then curve are steeper, curve are steeper, okay, that means the allowed bands get narrow, that means allowed bands get narrow. आपके जो अलाउड बैंड है वो आपके नैरो होते जाएंगे. ओके,
Yes, sir.
now what happens when your p is infinite? Okay, so I am writing here p is infinite. Okay, so if p is infinite, okay, in that case what will become, अगर p infinite है तो यहाँ पे हमारे पास क्या है, cos k है. ओके, तो अगर p is infinite है तो so but this whole things is equal is can go up to +1 to -1. Okay, so if you want to make p infinite, this term should be 0. Okay, if p infinite, then what, sin alpha a upon alpha a then should be 0. Okay, so when you put sin alpha a upon alpha 0, okay, what you'll get? Okay, so in that case what will become, then your cos alpha a is equal to your cos k. Okay, and that will give you what, that will give you alpha equal to k. Okay, now I know what is my energy, so my energy is what, okay, so energy is h cut square. एनर्जी क्या हो जाएगी इसके से बताओ,
h cut square k square by 2.
okay, so in the beginning we told what alpha, what by alpha is what, 2m e upon h cut square. Okay, now alpha equal to k, so my energy is h alpha square, okay, 2m, which is equal to h cut square k square by 2m. Okay, so this should be for p is equal to 0. No, let me, कुछ mistake कर दी क्या हमने, what mistake we done here, if this term is 0, okay, sorry, this term is 0, we have done some mistake. Okay, so this, if sin alpha is 0, if sin alpha is 0, that is sin equal to what, n pi, sin equal to n pi. Okay, so your alpha value will be what, n pi by a. Okay, so if alpha value is n pi by a, here we'll get e equals to what, we'll get n square pi square h cut square upon 2m a square. क्या आएगा, नहीं आएगा?
हाँ सर.
Okay, so if p is infinite, you're getting that potential well type of energy levels. Okay, that is discrete energy level. Okay, now put next case when p is equal to 0. If p is equal to 0, okay, if p is equal to 0, okay, in that case what become, this term becomes 0, then you become cos alpha a cos alpha A equal to cos Ka, and then alpha A equal to Ka. So alpha equal to K. That means when there is no potential, okay, your energy, I'm writing here, my energy become what? E equal to h cut square K square by 2m. So it's behaving like a free particle. Okay. So at last, let me draw a conclusion. Okay. So can I rub this one, all things?
Yes, sir.
So now let me draw the conclusion. So this is my energy. Okay. So I will have a discrete levels. Okay. Point number A, when electron is strongly bound. Okay. I'll get this continuous curve. Okay. B, when electron is free. Okay. And the third case, okay, the third case, what you'll get? You'll get bands. Okay. So you'll get some energy levels. जो नीचे के बैंड होते हैं वो जल्दी कम इफेक्ट होते हैं. So you'll get this bands. Okay. Okay. So when electron is when electron is, there's a periodic potential. Okay. And there is a periodic potential. Okay. When electron, we can write this one. When electron is in periodic potential. Okay. So see, we are not doing much mathematics in this band theory. Okay, because that will take too much time. And
Sir,
yes.
if when electron is free में these are energy levels, मतलब पूरा
continuous
होता है.
continuous होता है. Okay.
Okay,
So today we have seen whenever there is a periodic potential, okay, in that case we can take the help of Bloch theorem, and your solution will be like Bloch wave solutions. Okay. And when using Bloch wave property and purity boundary condition, when we solve Schrodinger equation, exact crystal potential is not solvable, so we have simplified this crystal potential by square wave type of potentials, and we will solve when Schrodinger equation for this set of potentials. Okay. We got this equations and we plotted a graph, and from here we got information so that your alpha values have a range. Okay. The energy is a range, and between this range there is a forbidden regions. Okay. That means you get bands. Okay. So this is today's conclusion. तो शुरू में जो करा था उसकी एक्चुअली जरूरत नहीं थी हमको, वो के पॉइंट की लेटर्स की वगैरह की, उसको फिर आगे फिर करना ही पड़ेगा हमको. ओके. तो आज के लिए ये तीन चीजें हमको क्लियर करनी थी कि हमारे व्हाट इज द ओरिजिन ऑफ बैंड्स. बैंड्स क्यों बनते हैं? बैंड्स आर फाउंड बिकॉज ऑफ दिस पीरियोडिक पोटेंशियल्स. ओके. सो आई एम स्टॉपिंग हियर. ओके. So tomorrow we'll meet. Okay. And we'll discuss something more about this band theory. Any question? Any question? If there are no questions, okay. So I'm closing this.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you.
Yes, sir.
Thank you, sir.
Mm.